Okay, ladies and gentlemen of Bridge class, I have one more video in this little series involving these two triangles here. And it ties to something called coordinate geometry. Coordinate geometry. This is where we're using information that's on the coordinate plane here, on graph paper, if you will. That's going to allow us to prove that triangles are congruent using some of our triangle congruence theorems and without having to go into elaborate proofs or anything along those lines. Okay, so, and I also want to review some work on the Pythagorean theorem that we've done in the past here as well. So this is going to be a quick video, hopefully. All right, so we're given a situation where angle A is congruent to angle D, and you guys should be already thinking right away, okay, what I need to do is I need to mark my givens. So here I'm going to mark that this angle here, A, is congruent to angle D. Okay. And our goal is to show that triangle ABC is congruent to triangle DEF. Now we have a whole bunch of ways to do this. We could use side, side, side if we wanted. We could use some other methods too, but I don't quite want to do side, side, side because I have an angle here already. So let's work maybe just as a something to consider with side, angle, side. And we already have our angle here. Angle A is congruent to angle D. And it might be somewhat obvious, hopefully it is obvious, that we have a couple sides that are definitely congruent here. This side and this side. Okay? You can just count it up. We have, this is 1, 2, 3, 4, 5, 6, 7, 8 across, segment AC, and then segment DF is also 8 across. So we can say that AC is congruent to DF. And so here's another side. Okay, we just need the first S, so to speak, and side, angle, side, and we're good to go. And to do that, I want us to look a little bit more closely back at the Pythagorean theorem. Again, I did this in a previous video, but I want to go a bit more slowly here. So the first thing we're going to do is we're going to drop a right triangle. That means we're going to go down from B. I'm going to mark this in a dotted line like this. Yeah? And that is distance 1, 2, 3, 4, 5. 5. And then going across, we have 1, 2, 3, 4, 5, 6. And our goal is to find out that length of the hypotenuse. And you can plug in numbers to the distance formula, but purposely I like to remember that the distance formula and the Pythagorean theorem are the same thing. So we say a squared plus b squared equals c squared. We'll call this length c. Yeah? And then a and b, it doesn't matter. So let's have a be 5, so 5 squared. And then b is the 6 squared equals c squared. 25 plus 36 equals c squared. 20 and 30 is 50, 5 and 6 is 11, and so we end up with 61 equals c squared. Take the square root of both sides. The square root of c squared is, of course, just c, and then we end up with c equals root 61. I'm going to scroll back out. What I need you to see here is that the same logic would apply to this hypotenuse over here, which I shaded in too heavily probably, but that's okay. This is also going to be root 61. And so we can say, using what's called coordinate geometry, this is coordinate geometry, that BA is congruent to E, D. And so now we have a side. This side here is congruent to this side. We have an included angle, which was given to begin with. And then we have this side here congruent to this side. And so the two triangles ABC and DEF have to be congruent using side, angle, side. And that's also the idea with coordinate geometry.